Alright, last video here that didn't have sound. We have a couple motion problems. So this first example, number 7 from the text, s of t equals 2t squared plus 4t. And the position is in kilometers and t is in hours, so therefore velocity, which is first derivative, is kilometers per hour. Acceleration is the second derivative. It's a derivative of velocity, and the unit's kind of weird. Kilometers per hour squared kilometers per hour is technically what it is, but it's how fast you're changing, right? Like velocity, think of speed. If you looked at your speedometer, how fast are you going? But you need to speed up to pass a truck driver, right? Now you're accelerating. How fast is your velocity changing? How fast is your speed changing? So it's a rate per rate. Or, you're doing 100 and you see highway patrol and you slam on your brakes, right? You'd have negative acceleration as well. Your velocity is decreasing. Okay, that's the idea behind it. That's the units. The work typically is quite easy though. So if it wants velocity, that's just first derivative, 4t plus 4, pretty straightforward. The units are kilometers per hour. If it wants a velocity at time 2, so at the second hour, how fast are they going? Then just substitute 2, so 12 kilometers per hour. Okay, the acceleration is the derivative of velocity, so second derivative. Well, the derivative of 4t is 4, and the derivative of a positive 4 is 0, so we just get 4 kilometers per hour squared, 4 kilometers per hour. Okay, it's a constant. So whatever this thing is constantly increasing speed, right? It's accelerating. All right. Next one, I put a few questions here, it looks like. We have this position function, s of t. I don't know why they use s off the top of my head, but it's pretty common. Okay, it's just a position. It's saying where is this whatever at a given time. Now, I drew a general shape of this thing, 160t minus 16t squared. It's a negative 16t squared, so it's a parabola going down. And that negative 16t squared comes up often. That's due to gravity. Not that that's too important in this class, but you'll see that often. Okay, so suppose it was asked, what is the max height of this thing? Okay, maybe it was a rocket that got shot up, and then, it maxed height, and then gravity pulled that back down, something like that, right? Or a ball was thrown in there, reaches its peak, and it heads back down. And when did it reach its max height? So the max height, picture something coming up, and as it starts to head down, that's when the velocity is 0, right? Like, at first the velocity is increasing, it's going up and up and up, and then it is weightless for just a second, split second, right? And then it heads down, negative velocity. So to find the max height, we know the velocity is 0. Well, the velocity is 160 minus 32t by just doing the derivative of s. Set that equal to 0, and you get 5. Okay, so at 5 seconds, it reaches its max height. Be careful of your variables, right? We only got t, so the max height is not 5. That's t at 5 seconds. So to get the actual max height now, we just substitute that 5 back into the position function, the original one. 160 multiplied by 5 minus 16 multiplied by 5 squared, and we get 400. In this example, we had seconds and feet, so 400 feet is the max height, and it happened 5 seconds into flight, or whatever it